Well, today we're going to continue to look at integration. Now, when you're integrating, we've looked at several ways you can integrate some problems in the past. Sometimes you can use a U substitution. Sometimes you can do longhand division and rewrite. Other times you can write it as a couple of different fractions by writing the top over the denominator as different fractions. And sometimes you can add special forms of 1 or multiply by the conjugate or rewrite using a Pythagorean theorem identity. Sometimes none of that works and you have to basically use an integration table. In the back of your book on page A20, Appendix B, is the first of several pages of integration tables, which are previously worked out problems where people know what the formula ends up being. The challenge in this section is some problems can be done with the U substitution, some can be done with longhand division, some have to be done with formulas, and so on. You don't know that ahead of time. Now this one here, you would not want to use a U substitution because your du would give you a 2x and there's no x shown up on top. Same thing with trying to do the natural log integration. You don't have an x shown up in your problem. So neither one of those work. If you do look in the back, on page A21, you can look at problem or formula 23, which is also given to you right here. You'll notice how this does match up. Now, with that 4, you could put the 4 in front, so it ends up being a 1 over. In your formulas in the back, your variable always has to be related to the u. Your a is always just a number. So for what we're looking at, what we have matches up great with that, where your u is your x and your a is your 3. So we integrate that, plugging your a's in of 3, your u's of an x, multiply the first two together, and you get your answer. Now, as a side note here, if you did want to start out with your tangent and want to take your derivative with respect to u, you know the tangent I'm giving you is u over a. You could draw yourself a triangle. Opposite is your u, adjacent is your a. You could use your Pythagorean theorem to get your hypotenuse. Now, if you took your derivative with respect to u, derivative of tangent is your secant squared, times your theta with respect to u, equals your 1 over a times your du over du, or that drops down to be 1. You get your du d theta to be by itself by multiplying both sides by the reciprocal of this, which is cosine. So you get 1 over a cosine squared. Once again, your du over du drops out. So then you're going to get a 1 over a. Cosine, according to your triangle, would be your adjacent of a over your hypotenuse, which does reduce down to this. Now, if you wanted, you could pull that a out. Now, what you started out with here is very similar to what we started out with in our initial problem above here, except they didn't have the a in front of it. And so that's why in your formula up here, they have a 1 over a in front of their arctangent. But that's as a side note. Now over here on the right, there's really no formula that works. However, we could use the idea of our u's here. Okay? Our arctangent rule that we use in the left doesn't work because we have that x on the top. But if you let your u be the bottom, you get your du to be this. So now you have your 4, but you needed a 2. So you basically have this right here. So this is your du. This is your u. So it's really a 2 integral of a du over a u, which you should realize that's just your natural log. So it's a 2 natural log of u plus c. And then plug in your u. Well, on this one here, there's no formula in the back that works. U won't work because you have an x squared on the top and an x squared on the bottom. So we're first of all going to do longhand division and rewrite this. So you're basically going to go ahead and do your longhand division. When you do that and you look at your quotient, what you have up on top, you're going to have a 4. You're going to get a remainder of negative 36. So you're going to take your remainder of negative 36 over what you were dividing by. Now we can go ahead and work that out. Integrate your 4. That's not too bad to do, and you know you just get a 4x. Here, you got a 36 over this. Well, you could pull that 36 out. Now what we have right here is just like what we had in the last problem, so you know that that is just your arctangent formula that we were just dealing with. So you get your negative 36. Your a is your 3, your u is your x. Well, the negative 36 and the 1/3 is your negative 12. So it integrates to this here. So in this case, we did our longhand division, integrated part of it like normal, then had to use a formula for the other part. Well, for this problem here, we're going to go ahead and say, oops, just a second here. Sorry about that. I noticed a mistake I had down here. I had it as a definite integral when it's an indefinite one. So we'll go ahead and look at this. We're going to first of all rewrite our problem as separate fractions. So we'll take the first thing on the top over the bottom, plus the integral of the second thing on the top over the bottom. Now the second one, I'm going to pull the 3 out of the front. Then what you have here matches up perfectly with the formula in the back, happens to be formula 41. Here's your formula 41. Your a would have to be your 2. Your u would have to be your x. So then this last part integrates into a 3, the 3 from in front, arc sine of x over 2 plus c. Now this first part here, you could really do a u. You could say, well, u is my 4 minus my x squared, so therefore my du is my negative 2x dx. And you'll notice I have this showing up and this showing up, but I don't have that negative 2. So that's why we have a negative 1/2 in front of that integral. It then ends up being a du over u to the 1/2. So it's really a u to the negative 1/2 du here. Then you increase your power by 1. Okay, and so then we get this, which does simplify just a little bit down to a negative, basically square root of your initial u of a 4 minus an x squared. This one here, you'll notice with most of the formulas in the back that they're all in the form of something squared minus something squared on the bottom. So if you rewrite the bottom as a 4 squared minus an x cubed all squared, then it matches up with one of your formulas. But you'll notice if your u then is your x cubed, your du is a 3x squared. So it matches up with one of your formulas. Now you don't have a 3 showing up in your problem. That's why we have a 1/3 in front here. Matches up then with our formula. This is your formula 41 here. So you just go ahead and rewrite, then substitute in what u is, and we get our answer.